Here we go. Okay, so here, again, we have this example. So here are basically what you have to do in each case, but let me go through it. Here we go. So for instance, in the annually, right? I mean, in either case, you can see it really depends on what your N is. So if your N, for instance, is 1, right? That's what annually is. This is what you should get, right? Again, your R is 0.05, 5% written as a decimal. Your N is 1, okay? And when you do all that, right, you do what's in parentheses first, and you raise it to the 5th as well, like so, and you should get this. I mean, if you got something different, you know, say something or do the hand raise feature. Okay. I mean, that's for annually. For quarterly, as I said before, that's when it's compounded 4 times a year. So we get this wonderful thing. Basically, the only difference is that this one and this one get replaced by 4. And I'm pretty confident my calculation's right. This is what I got. That's cool. For monthly, instead of 4, we have 12. And that's what we got here. Okay. And for 365, which is daily, we get this. Okay, as you can see. So we get this thing. Now, okay, let me see. Let me just double check something. Did everyone get these numbers? Here, you know what? Let me do a poll then. This way. You know, if you got something different, I mean, I don't think I did something wrong. At least I hope I didn't. But I'm pretty confident that mine's numbers are right. Sweet. Looks like yes, yes, yes. Yeah, right. That's fun. Okay, that's good. Oh, wrong one. There we go. Okay, looks like everyone did good. All right. Okay, good. All right. So it looks like I guess we're all in the same boat. So that's good. Let's keep going then. Okay. Yeah, let me stop this. Good, good, good. Okay, so let's keep going then. So now I just rewrote the numbers here, but basically, if you were to look at all 4, right, you could probably see that, you know, if you had to make a choice, you know, if you had a choice of which one to take, you know, how often for the account to be compounded, you could probably see that you would want to compound it daily. From what it looks like, you know, the more it's compounded, the more money you're going to make, right? Because mostly because what's going to happen is you're going to build interest on interest already earned, right? So hopefully you can see that the more it's compounded, the more money you would make. Although it's not much more than monthly, as you can see, right? I mean, here it's only about what, like a little less than $7 more. But you're still going to make more money, though. Okay, well, what if it were to compound always, every second, you know, more than every second? What if it was being compounded all the time? Well, could we figure out how much money we would have? Well, it turns out the answer is yes. And it would take calculus to prove it, but it turns out this is what would happen. You have what's called continuous compounding. Basically, if you were to compound all the time, if the account somehow was constantly being compounded, theoretically, then the amount in that account would be given by this. I think most people call it PERT. So P sub 0 here, right? That's your principal. R is the APR, T is time in years. But when you see this E, that's what's different, right? We don't have 1 plus something over N to the N times T. We have this E here. There is a button in your calculator with the label E. And I know in the Desmos calculator, you know, the what do you call it? The not the graphing one, but the other calculator has the scientific calculator. It's right in the slide. I couldn't think of the word, but basically there, E denotes a number. It denotes a number that's irrational, and it's between 2 and 3. It actually turns out to be about 2.71. So you can do e raised to something that is an exponential function. The way you formally define e and where it actually comes from, you would have to take calculus for that. It's fun, but you would have to do calculus for that. Okay? It's actually E named after Euler. I think he was a Swedish mathematician, if I remember correctly. Definitely did a lot of very nice math work. If I remember correctly, I think he was blind, and he still actually published as well. So amazing stuff. But basically, E is just a number between 2 and 3. The fact that it's irrational and how you define it, that's way beyond the scope of the course. But, you know, this is what would happen, though, if it was always being compounded. So it's almost like the most you can make, so to say, from compounding. So that's what they call the PERT. I think they call it PERT, but that's what you can do. But for instance, let's suppose with that same amount, if it was compounded continuously, this is how much you would make. I mean, make sure you know how to use that e to the x in your calculator. If you don't, you know, let me know, please. Okay? But this is actually what we get, though. Now, are there accounts out there that actually do compounded continuously? I want to say yes, but I can't think of any explicit ones off the top of my head. So, all right. So we have this done. Okay, let's keep going forward. Let's do now we're going to look at the annual percentage yield, that APY. Before we get to that, are there any questions about this, compounding continuously? Okay. Well, this is actually, you could probably see from the formula, it's actually a relative change. It's actually it's the percent increase in how much is in the account after a year, as you can see. So this is the principal, in other words, right? It's the percent increase from the principal in the account after 1 year. And here they actually plug in the formula, right? And then algebraically, p sub 0 cancels and you're left with this. So the formula itself is not that bad. What's really interesting is notice that p sub 0 does not come into play. The only factors that do are R, the APR, and N, how many compounding periods there are in a year. So in a sense, this kind of confirms what we were saying before. The more it's compounded, the more money will be in there. Up to a certain point, though, I guess. So as an example, if we were to calculate this here, the APY, let's calculate it for an account that pays 4%. It's compounded monthly. Again, I didn't tell you what P0 is, the principal, but that doesn't matter, as you can see from this calculation. Okay, so our N, it's monthly, right? So our N is 12. The APR, the R, is 4%. Now, if you were to do this calculation, minus 1, of course, you get this. So it's about 4.07. pretty close to R itself, actually. So I think it's because if you use R itself, that's like simple interest, but I have to look into that because I could be wrong about that. But anyway, this is what you would get, though. That's the APY, as it's called. Okay, here is another example, but before we do that, let me pause the recording.